sooner or later. And if you've got it, you probably know it, because it's a rather frustrating disease. You end up with term abortions, and a lot of them actually are pretty easily diagnosed just by looking at them. If you look at these guys, if you look on the hard mucosal surfaces, just a tremendous number of petechial hemorrhages. Okay, just little red dots everywhere. You can see it in the eyelids. Probably one of the things that we usually check, the first thing we check is right in front of the shoulder. The lymph node there feels like you've got just a massive Frankfurter laying in there as opposed to a small node. I mean, the fetus should be in a sterile environment in the cow, and because of this infection they respond just tremendously. So you think when you get the crud and your lymph nodes start to swell up, well, I'll tell you what, these things, you cut these things out, they're literally giant. If you look inside, take a pocket knife and open these guys up, one of the things you'll often find is that when they're laying there, they look like they've got a distended abdomen. It just typically can be filled with fluid. We refer to it as ascites. Thymus, your sweetbreads, you wouldn't want to eat those. When you look at them, they're just solid instead of white. They're just solid red from hemorrhage. The enlarged spleen, we've seen these spleens actually come all the way from the back, wrap all the way around the abdomen and head up the other side. These are huge spleens, and again, it's one of the targets of this bug. And sometimes you look at the liver, it can be all mottled and have very rounded edges. What did I do? Go the wrong way? This thing does work, doesn't it? Which one? Oh, that one. Okay. Okay, so as John already referred, this disease does have a rather colorful past, especially when it comes to people who are trying to resolve this. But it's felt that it's existed in the state for since the 20s. The School of Veterinary Medicine at Davis was founded in '48, and our present dean told me that one of the driving reasons for forming the vet school was to address all these abortions that you cattlemen were having. That we knew it wasn't brucella, so what was it? And it's I guess the first group that were working on this. Actually, I knew both of these fellows. They were before my time, but they were quite sure it was a chlamydial disease, and it was basically assumed that one could resolve this problem with a chlamydial vaccine. They developed a vaccine, but again, something like foothill abortion, it was difficult to study, because how do you reproduce it? Well, they had no agent, and they couldn't culture an agent, so the best they could do would be to try to vaccinate a bunch of animals with chlamydia and put them out on the range and see what happened, and so you can never be sure what your exposure is going to be. Question?
What's chlamydia?
It's a type of bacterial infection. But at any rate, they've assumed this is what it was, and then Peter Kennedy, one of our pathologists that retired quite a few years ago, had a look at this, and he waited until they were at a scientific meeting, and Delmer got up and gave a talk about this was a chlamydial disease, and then Peter got up afterwards and said, no, it isn't. And according to the story, they almost came to blows in this meeting in Michigan. So there was no friendship there, even though they were in the same school. You go to the 70s, and they figured out, Schmidtman and Ed Loomis and Bob Bushnell, Mike Oliver, Glenn, you know a lot of these people, figured out that this tick was the vector. This was what was transmitting foothill abortion. So actually that was a huge step forward, because now at least you could go out and collect these ticks, and you could feed them on susceptible heifers, and at least you could recreate the disease to try to isolate the bug. And boy, did we run through a lot of bugs. Paul Kimsey and John Kendrick found this kind of uncharacterized virus that they looked like a retrovirus by EM. They pursued that for some time. Then a fellow in Berkeley found this spirochete-like bug, Borrelia coriacea. He found it in the tick. It was just natural assumption that this was going to be the agent. And John Oswald, an immunologist at the school, found these uncharacterized spirochetes. So we were pretty sure that this was what the agent was. It slowly fell apart. There was a search for a retrovirus again, and this consumed quite a bit of time. And ultimately, in 2005, we finally published what at least we'd like to believe is the etiologic agent of EBA. It's an extremely unusual bacteria. So, diagnosis, the history of the dam, been in the foothill areas. Has the dam been where the tick is? Gross and microscopic pathology, that's the way foothill abortion has been diagnosed forever, is by pathology. And there are lesions that are just absolutely unique to foothill abortion. And serum immunoglobulin, the antibodies, you can find these elevated proteins in the blood of a term fetus, because the term fetus should not have antibodies to anything. It should be living in a sterile environment unless it's infected. So just some facts associated with foothill abortion: distribution, California, Nevada, and Southern Oregon. I mean, that's where we find the disease. We'd probably get a lot more dollars to work on this if everybody filled their pickup up with ticks and headed east and get these things spread out. Share your grief with the rest of the western U.S. Up to 90% fetal mortality when it's first exposure. So when we see the greatest wrecks is when somebody buys a ranch that isn't stocked and they bring in their lone livestock. They've never heard of foothill abortion, and they learn. They really learn the hard way. We've seen some of these happen in Nevada, at least that I've been associated with. And after you've lost about 80% of your calves, it's time to sell. I talked to a fellow the other day that lives out down towards the Oregon border, and I don't think he was very well liked by the neighbors when he moved in and bought this ranch. And he brought in a whole bunch of susceptible heifers, and he lost almost every single one of them, aborted, and he sold them all. He thought bad heifers. He went out and he bought another set, and he brought those in. If he'd just kept what he had, he'd have been okay. But so he had 2 rounds, and but then somebody let him in on the secret of foothill abortion. The window of susceptibility, 90 to 120 days gestation. That's a pretty tight window, okay? But obviously, it's not too tight because it is such a problem. But if you have exposure before or after this period, okay, you typically aren't going to have a problem, which is how you can kind of manage around this to a certain degree. Term abortions, weak calves, we see them both. Diagnosis, 100 days post-infection, prior to the development of pathology. So this is a real curious bug. It gets into the cow. We don't know how long it takes to get into the developing fetus. And if you go in and you actually, if you take these cows to slaughter and you take that fetus and you look 50, 60, 70 days later, that fetus looks absolutely perfect. Okay. The pathology develops incredibly quickly as one approaches term. So when we talk about there's a picture of the tick here, the distribution. They found the tick in Mexico, California, Nevada, and Oregon. This was the clue, I guess, that led everyone to kind of overlay the distribution of this tick with the distribution of foothill abortion, and came to the idea that this is probably what it was. These ticks are rapid feeders, and that's why the tick hasn't spread out through movement of cattle. Okay, jumps on in 15 or 20 minutes. It's had a meal, and it falls back off. And 2, when an animal is moving, if the tick is going to fall off out in the brush, it's a dead end for that tick. Because these ticks don't crawl up into the brush and jump onto livestock as your hard-shelled ticks do. Where you find these ticks is around bedding areas. Okay, so the tick is pretty limited in how it's going to get a blood meal. That animal is literally pretty much going to have to lay down, and then that tick will come to the CO2 that animal's putting off, and it'll crawl on, grab a snack, and jump back off and get back down into the litter. The larvae, the nymphs, there's a larval stage there. Those actually can stay on the animals, like I say, probably 7 to 10 days. But once they hit this nymphal stage, then they feed very rapidly, and then they'll mature into adults, males and females. They're long-lived ticks. It's felt they can probably live around 10 years, as long as they can get a blood meal now and again. And we've had them in the lab, and we've had some of these ticks live 3 years without a blood meal. Some of them get pretty desiccated and don't do too well. But these these are tough ticks. We collected some the other day. We were going to take them apart and look for the bacterium, and we put them in our freezer for a couple of months. And these ultra low freezers are like minus 80 degrees centigrade. And I took a bunch of them out, and I had them out there on the bench. And I don't know, I went to get a cup of coffee or something. I came back, and they were gone. And I tell you what, it doesn't take them long to wake up. These are tough ticks, so it's not surprising that they can. It made a few of the people in the lab kind of nervous. They weren't too sure where they went, but they're actually a pretty timid tick. The greatest activity of these ticks is May and October, and a lot of people, if they fall calf, that they can at least ease the pain a little bit. Tick collection. Okay, so for years it was the only way to transmit this disease. Actually, we've come up with pretty clever ways to trap these ticks. What you're looking at here is those little shallow bowls that you put your potted plants in that kind of have a slick side to them. We take a little canvas and tape it around the outside, and then put this out here, a little piece of dry ice in the middle, and these ticks are coming up. They fall into the hole here, and they can then we can collect them. They come in a variety of sizes, and this only takes about, like say, 15-20 minutes for a flat tick here before feeding to become a very fat tick. Okay, so transmission. I mean, for years it was the only way. Then, once we did know it was a tick, we'd feed ticks on these heifers. I think we might have problems today. I don't know how easy it is to get permits. People don't think this is a really kind thing to do. But what you do is we typically shave the back of the heifer. Then we take some of this rubber cement, and we tape a cap on this thing. Then we'll cut a hole in the cap and drop the ticks in here. Wait for about 20 minutes. We actually staple this up and make sure we keep the heifer in the chute, because they're pretty mean ticks. And then take the ticks back off, and of course then you got to hurry up and wait to see if you've transmitted EBA. And it is a hit and miss process. I mean, even feeding ticks like this on pregnant, susceptible heifers, sometimes we'll only get 10-20% of the heifers that will actually, the fetus will get infected and abort. So it's rather frustrating. And I've read that some of the early work, people were feeding 700 and 800 ticks on a single heifer trying to transmit the disease. So it's a rare tick, actually, in fact, that carries the bacteria. So when I got involved, the first thing, I didn't want to become one of these people that retires and hasn't solved EBA. And I think hopefully we're getting close. What we did is we took the effort to figure out a challenge system that we could reproduce foothill abortion. And what we were able to determine is on a very select number of aborted fetuses, if we took the thymus out of that, we ground it up and we made a homogenate. Actually, we just used one of these things you make a milkshake with, put a little glycerol in it and put it in the freezer. We were able to come up with an inoculum that we could reproduce clinical foothill abortion 100% of the time. The problem is it's not very stable. So after 2 years, you're back to the drawing board again, going through fetus after fetus after fetus, grinding this tissue up, preparing it, aliquoting it out, freezing it, and then obviously we had to have a secure source of susceptible animals. We've gotten to the point where we bring all our animals in from South Dakota, because even though as you move east into Nevada and you don't see foothill abortion, there still seems to be some exposure, okay, because they are partially resistant. So if we go out to eastern Nevada and we buy a bunch of heifers and bring them in, we'll find that maybe 30-40% of them are susceptible and the rest aren't. So it appears that you've got, as you move further east, the density of this tick probably is falling off. But at any rate, with the ability to reproduce clinical disease, we did some antibiotic studies, and we were able to determine that the agent was susceptible to antibiotics. And those antibiotics, though, have to be on board at the time the animal's exposed. Because our feeling is once that bacteria gets into the heifer and gets across the placenta into the fetus, then there's nothing going to do to stop it, okay? It's a the pathogenesis is just extremely unique. So it is, though, like I say, tetracycline, penicillin. It's extremely antibiotics sensitive if one has that on board before you challenge. So at any rate, We finally determined what this bug is. We call it, I'm not a very clever person, I call it the agent of EBA. But it's something called a myxobacteria. This is it's in a family called delta proteobacteria. There's a huge, huge number of bacteria. And there's only one other pathogen in this whole group of bacteria. And it's a disease of pigs. And it's a bacteria that causes an enteritis. And they had the same problem with this bacteria. It was only identified about 2 years before we found this bug that causes foothill abortion. And you can't grow it. It just basically will not grow in culture. And so this kind of gave, but they developed a special stain that they could see this, it was called Lawsonii intracellularis, you could see it. And so we tried some of these stains, and presto, what nobody could see in these tissues for 50 years was now visible. And what we were able to determine is just different ways of seeing it. There's your bacteria here. You use these specialized stains. These are little red dots here. Your bacteria, you can see it here in the lung. There's an electron micrograph of what we assume is the bacteria. But all of those years, we could just not see those bacteria in any of those lesions. And it just because it's such a unique bacteria, it wouldn't stain. And with these modified silver stains and then some of the immunologic stains we came up with, we could stain it. So at any rate, once we realized what this was, we had a molecular probe. We could start looking and seeing where this bug was. And this we extracted DNA from all of these ticks. It was quite a project. We were talking about graduate students earlier. This graduate student was very glad to leave my lab. But dissected all of these ticks out and used this probe to see if they could find the bug. And these show just the percentage of ticks from different areas, okay, that harbored the bacteria. But what we came to appreciate was that probably only maybe 1 in 500, 1 in 1,000 ticks actually has a sufficient load of bacteria in the salivary gland where it can actually transmit the infection, which tells you how much exposure your heifers are getting, your cows are getting to this tick. I mean, they're everywhere. So the vector at sea level, we found these ticks up at 9,000 feet. You can't outclimb the tick. We found it in the pinyon pines and the junipers. That's where it's easiest to find. I always struggle in the oaks. We know it's there. It's not so easy to collect there. And you go out into the sage, and now and again you'll find a tick, but it probably just fell off, and its lifespan is limited. Only occasional tick has enough of the bacteria to detect without an extremely sensitive assay. Bloodmeal does not appear to enhance the pathogen detection. We thought there's certain bugs that when ticks pick them up, if they have a blood meal, it'll amplify the amount of pathogen that is there. That doesn't occur with foothill abortion. We found no significant difference in the percent of infected nymphs, males and females. And what that means is, as the older the tick gets and the more blood meals it has, as a population, the ticks don't become heavier and heavier carriers of this bacteria. The percent of ticks infected is highly variable. Pathogen resides in the salivary gland, and we've had no evidence to date that this bacteria gets transmitted through the eggs into the larvae. So we've kind of played a little bit around looking for a reservoir. Is it in deer? That we don't know. Some folks over in Nevada got involved with a coyote thin-out project, and so we went through a lot of coyote tissues and nothing there. It's possible that maybe it's carried by rodents. My personal bet is that it's in the soil. Okay, I think it's some strange soil bacteria that has somehow gets into a subpopulation of ticks because they're living down in that litter, and then gets inadvertently transmitted to a pregnant heifer. So, once we knew what it was, we tried to characterize this thing. In vitro propagation, we've tried everything. Synthetic medias, cell cultures, it just will not grow. So we're left with high-tech approaches we call proteomics and DNA manipulations. We have had some success watching this bacteria grow in what we call a bovine adherent spleen cell cultures. And really all we've done is we take a freshly aborted fetus that was not dead more than 8-10 hours, and you can actually culture some of the cells out of the spleen, and you can see all of these, but it's hard to see here, there's a specialized stain we're using here, but all of these bacteria you can see inside of the cells, okay, so it starts out pretty low, and you can see this infection rate increase, but it's just not realistic. One can't get enough of this bacteria to do any good. Probably one of the reasons why the antibiotics, once that bacteria gets crossed into the fetus, you're pretty much toast. The bacteria gets into cells of the immune system, and that's what causes the problem. We've done some pretty fancy proteomics type stuff. All these little dots are proteins that we divided by their size, and tried to use something called mass spec. It's a high-tech way to look at peptides, trying to find something we can work with. All for naught, mainly because there's just nothing out there that is similar to this. So to finish with very quickly, we've looked for animal models. Sheep don't work. Gestation is too short. Okay, we can put it in, but we don't see anything. But these guys, these mice, these are immunodeficient mice. And we finally figured out we can actually grow this bacteria in immunodeficient mice. They have no immune system. It takes just as long to kill a mouse as it does to get into a fetus and cause disease in the fetus. It takes about 100 days. But this is what we see here. You see the enlarged spleen. And out of this spleen, there's a very clever way. What you're looking at here is spleen cells out of this mouse, and these are actually spleen cells that are infected with that bacteria. Using that, we've been able to purify this bacteria out of those spleen cells. All these little bands here are just proteins of that bacteria to which the fetus has responded with an immune response. So it's giving us some direction of where to go to try to get a vaccine developed. So what kind of a vaccine are we looking at? Well, I guess it's possible we could propagate this pathogen in these skid mice. These, of course, if you look at the price, they're about $28,000 a pound. These are extremely expensive mice, but right now it looks like we can infect a heifer probably with as little as maybe 200-300 infected cells out of a mouse spleen and cause abortion and cause Foothill abortion. So it's possible, in fact, that we could maybe vaccinate maybe 300-400 heifers with the cells from a single mouse spleen. Even though that mouse is expensive, it might be realistic. And then the other approaches that we're taking is a proteomics approach. We're creating a DNA expression library. The genome is being sequenced. So hopefully we'll move forward. The biggest trick here is going to be able to get, as mentioned before, it's a vaccine company interested. It's going to be an orphan vaccine. We've talked to Pfizer, and Pfizer's expressed some interest that they do have a special program that sometimes they will take something and make a vaccine when they know they're not going to make any money, just in the hopes that to buy some of their other products, I suppose. Thank you.